Today we're talking about graphing square root functions. So the base function we'll be talking about is y equals the square root of x. And you want to treat this function much like we've treated other functions. You want to find a table of values so that you can graph it. Now think carefully about the kind of values you want to use. 2 is not a great value here because you're going to end up with some irrational y, and that's not going to be easy to graph, obviously. But using values like 0, 1, 4, 9 are good values to use. Obviously, you don't want to use negative values either because you're not going to find a rational square root, real square root of a negative. One of the things you're going to be asked to do is find the domain and the range of this function. Well, let's look at our standard function to begin with. Okay. The range of this function, well, what kind of values are we going to get out of a square root value? Well, just look at the table we made. We don't have negative values that we can put in for x. We have positive values and 0. So we know for the purposes of our domain, we can't put in negatives. So domain x is going to be greater than or equal to 0. And the same thing can be true said for y. Okay, it's going to be greater than, for the range, y is going to be greater than or equal to 0. That changes a little bit as the function changes. For instance, let's look at this function. I'm not sure what kind of domain this function is going to have, but I know I can't have anything less than 0 underneath my radical sign. So what I can do is take my radicand, what happens underneath the radical sign, and say I want that to be greater than or equal to 0. Add 9 to both sides. Divide by 3. X is greater than or equal to 3. And there's your domain. In this case, your range actually stays the same. Your range hasn't shifted here. The shape of the graph might have shifted a little bit with this 2 out front, but the actual beginning point of the graph, how much y value it covers, y is still just greater than or equal to 0 in terms of your range. And we've talked about other functions like with parabolas, how we can make it wider or more narrow or move it up or move it right and left. Well, the same thing is true for these radical functions. We can do what are called translations or slides. We can slide them around. So if we look at the function of y equals x squared plus 2 with the 2 outside the radical sign, you'll notice as we plug in values here, when we plug in 0 initially, we used to just get 0. Now when we plug in 0, we're going to get 2. When we plug in 1, we're going to get 3. When we plug in 4, we're going to get 4. The whole graphs get shifted vertically, get shifted up vertically. Okay? So when we have a number outside of the radical sign like this, we're translating the function up vertically. Likewise, if we have something going inside the radical sign, we're going to be shifting this left and right. And you can even see the change happening in the domain, because now my domain, I can have numbers like -1, -2. In fact, I can start with something like -3 and get out a 0. Plug in a -2 and get out a 1. Okay, so now we're shifting this left and right. And in fact, this one's going to shift left because we're adding 3 here. So see how our first number is no longer 0 but goes back to -3? Okay, so that means we're shifting the whole function to the left. We're sliding it, translating it left. So if we want to translate it up and down, we have numbers outside of the radical sign like that. If we want to shift it right and left, we have numbers inside the radical sign. And that's the bulk of graphing radicals. Other than that, it's just a matter of making tables. You can even use your calculator to get a shape of what these look like. Just make sure you draw it out.